Okay, we want to recall our distance, midpoint and slope formulas, and we're going to be just using the formulas straight out, substituting straight into them to find the distance, midpoint and slope, and then we're going to look at what happens if we've got the distance and one of the coordinates is missing, or we've got the midpoint and we want to find one of the missing coordinates there. You get the gist. So a little bit of algebra will be used as we go along. So let's just go back and recall our distance formula. If I've got this coordinate, our Cartesian plane here, I've got this point here, let's call this A, and we've gone across 2 and up 1, so that's our point 2, 1, and then we've got our point here is across 6 and it's gone up 4. So that's pretty simple there. And what I'm wanting to do is I would like to find the distance between point A and point B. Now I could grab my ruler and measure, but you know, it's going to be a bit annoying, especially if I've got really large values. I don't want to have to draw them every time, and I don't want to have to draw it to scale every time. So we recall our good old friend Pythagoras. Yep, he pops his head up there every now and again. So Pythagoras, if you remember, it does indeed deal with right-angled triangles, so we're good to go there. And we say the two lengths that make up our right angle, we call them A and B, and the diagonal, which is the longest side, also known as the hypotenuse. We don't want to write all of that, so we just call it C. We know that Pythag says A squared plus B squared equals C squared. So that's what we're going to use to find this length here. But how do we find this length of A? Well, that's how high it's gone. Now, it's got a height up here. It starts at 1, and then it goes all the way up to 4. So you can see 1, 2, 3, 4 take 1, that just happens to be 3. So the difference in your y values, right, your y value here and your y value there, gives you 3. Similarly, the difference in your x values, right, 1, 2, 3, 4, so we know that's 4 across there, and lo and behold, 6 take 2, right, your 6 here and your 2 here, that just happens to be 4. And that's how we get our formula for our distance, right? If we have 2 points, let's call them x1 and y1, and we'll call the second point x2 and y2, then we say that our distance formula is the difference between our x values, so x1 minus x2, and according to Pythag, we'll square that, and then we'll find the difference of our y values, y1 take y2, and we'll square that. That's what this tells us, and that's going to equal our distance, right? Our distance squared. But I don't want d squared, I just want d. So how do I get rid of a squared? Right, the opposite of squaring? Correct, square rooting. So we will square root that whole thing, and that's our formula for finding the distance between 2 points. So let's apply it to our little system here. I always like to write down the points that I have. Okay, so we've got 2, 1, and I've got B is 6, 4. Always write your formula down. It helps avoid any silly errors because there's going to be numbers flying all over the place here. So make sure we write that nicely, nice and neat. Okay, and x1 take x2, y1 take y2. Now I'm going to call that x1, x2, y1, y2. Some of you might be wondering what happens if you did it the other way around and you called this x2 and x1. Well, you'll see in a minute, it's not going to make a difference. 2 take 6 squared plus 1 take 4 squared. Now, 2 take 6 is minus 4. Minus 4 squared, okay, negative times a negative, we know it's a positive. If you're being a little bit sloppy and you're just doing everything on your calculator, can I just warn you, if you type in minus 4 squared, your calculator doesn't give you 16 positive, it gives you negative 16. Does that mean the calculator is wrong? Nope. Means you've entered it in incorrectly. So technically you need to put brackets minus 4 squared and then you'll get the correct answer. Personally, I just ignore the negative. If I was to, have a brain fade, I needed to work out what 4 squared was, just ignore the negative because I know a negative times a negative will give me a positive. Okay, so we can just pop that straight in. Well, I'm not even going to go to the calculator here. We're going to go, that is minus 4 squared. 1 take 4 is minus 3 squared, and that's going to be 16 plus 9 square root of 25, which is 5 units. And that's it. That's how simple it is. It's just put your information into the formula and then away you go. And quite frankly, you could have gone straight here and gone square root, right, bracket 2 take 6 squared plus 1 take 4 squared, cut out all of that other work, and bang, you get your 5. So pretty straightforward. Let's just do one more. So I'm going to erase this. So you might want to copy it down or pause the video and copy it if you wanted that example. Okay, so we've got 2 new points here. Same old, same old. Make sure that you write down your formula. Helps you remember it as well. Okay, and we're going to substitute our information in. This is our x1, this is our x2. So when we pop that in, it's 3 take minus 1. So a negative and a negative become a positive. And really, that's the only thing you have to watch out for. Minus 2 take 0 is minus 2. So pop that in, 3 plus 1 squared. So that's 4 squared, which is 16. Minus 2 squared is 4. Going along swimmingly, 16 plus 4 is root 20. Now you could leave it like that. However, if you pop that into your calculator, right, root 20, or you even type in root 16 plus 4, it doesn't leave it like that. If we press enter, we get this answer called 2 root 5. Okay, and that is what we call its in simplest form. Personally, when I'm dealing with distances, sometimes it's nice to actually put the actual answer down in decimal. But why did we have this 2 root 5? It's because what we did is we simplified, or the calculator simplified, this surd slash square root. And to do that, we wonder, or we ask ourselves, are there any square numbers that go into 20? Now, square numbers are numbers that we know the square root of. So I know the square root of 4 is 2. That makes 4 a square root, a square number. I know the square root of 9 is 3, so 9 is a square number. The square root of 16 is 4, 16 is a square number, etc., etc. Okay, so one of the things that I'm allowed to do is I say, well, are any of these numbers, 4, 9, 16, go into 20? And we know they do, because it's 4 5s give me 20. And one of the rules of surds slash square roots is that I can separate them. So the square root of 4 times 5 is the same as root 4 times root 5, and lo and behold, the square root of 4 is 2. So that's how we turn root 20 into 2 root 5. So as you come across, if you come across any of these in your working, maybe just pop them into your calculator, check that it's the same decimal, and then you can see if you're right or not. Okay. Otherwise, feel free to practice this because it's a handy little skill to have. Okay, so now let's get into a more algebraic use of the distance formula. So here's a typical question that I've got 2 points and I know that they're 6 units apart from each other. The problem is that I don't know what one of the coordinates is. So you sort of think, what are we going to do here? Well, the dead giveaway is that it says it's 6 units. So that means we're dealing with the distance. So what shall we do? Yep, write down our distance formula. Now feel free to go and look it up, but hopefully you've written it down so many times by now that you know it off by heart. So we've got our formula, and now we look at the information that we have and we will substitute the information that we have into our formula. So now, instead of writing d again, we know that the distance is actually 6. So that becomes 6 equals, it has a nice square root, so we'll pop that. And then it says x1 take x2. So here's my x1 and here's my x2. So we'll just pop that in as 4 minus b squared. We keep following the formula here. y1 take y2, so that'll be minus 1 take 3, all squared. And now we ask ourselves, what is it that we could do with this? Well, I want to try and get to b. I need that all by itself. The thing that's bothering us is this square root. We're going to do the opposite of square root. The opposite of square rooting is squaring. Correct. So we're going to square both sides. The square of 6 is 36. And when we square the right-hand side, the square root disappears. So we're now left with 4 take b squared. Minus 1 take 3 is minus 4. And 4 squared is 16. Now you might be tempted to expand this bracket here, but don't. Okay, I'm going to get rid of the plus 16. To get rid of a plus 16, we do the opposite. Opposite of plus is take, so this becomes 36 take 16. And I'm left with 4 minus b squared on this side. 36 take 16 is 20. Okay, and now to get b by itself, instead of expanding, I can go, well, hang on, how do I get rid of this squared? The opposite of squaring? Correct, square rooting. Now I'm going to square root this 20, and I'm left with 4 take b. Before we go on, just want to check, are we totally happy with the answer that we have here? Because I just want to remind you or ask you, what's the square root of, let's say, 9? And I know you're all going to go, yep, 3. Correct. Because 3 squared equals 9. But remember, there's another number that when I square will also give me 9. And that's the negative. So negative 3 squared will also give me 9. So that means when I take the square root down here, I actually have to pop in that I could have a plus or a minus there. Okay? And now we're just going to get b by itself. It's a negative here, so I'm going to pop that on the other side. So it's going to become positive b. The 4 remains there, and this plus or minus root 20 goes on the other side. And I don't have to change that because the plus root 20 becomes the minus here. The minus root 20 becomes the plus. Okay, so this is just a shortcut way of giving me two answers. The two answers are b could be for plus root 20, or b could be for take root 20. Right, now just to get an idea, what do those values actually mean? So 4 plus root 20, and remember we could simplify that to 2 root 5. Yep, there it is, 2 root 5. Let's get a decimal answer of that. So 8.47. So that's 8.47. And what is 4 take root 20? Okay, minus 0.47. Now I hope you're asking or wondering, why are there these two solutions? And to answer that, let's have a look at what this looks like graphically. Okay, so a quick little Cartesian, sorry for my wobbly line there. Oops. Okay, so let's roughly pop in A. So it's 4 minus 1, so A would be here. And B, right, is B3. So anywhere along here, but it's going to be, here's 3. It has to lie somewhere along that line. Okay? But it has to be 6 units away. So B is somewhere on this line, but it's 6 units away. Now, it can't be directly above because that would actually be 3 units. there. Okay, so the minimum distance would actually be 4 units. Anyway, so it has to be 8 units, and it could be 6, I don't know where 8's come from, it could be 6 units that way, and it could be 6 units the other way. So that's why we get our 2 solutions over here. Okay, hopefully that makes sense. So again, this becomes routine because all I can do, or all the textbook can do, is change these values. Okay, so instead of being 4 and minus 1, it could be, I don't know, minus 3 and 10. Just substitute them in and go along on your merry way. But your algebra skills will be kicking in. You know the opposite of square rooting is squaring, right? It's the bit here. Try and not expand, right, the bracket that has your variable in it, the unknown. Instead, just square root. And if you abide by that, hopefully that's all good. We'll do the slope and midpoint in another video because this has now gone on a bit.